Good morning. Today, what we're going to talk about is we're going to figure out how to write equations for lines that are parallel to another line and lines that are perpendicular to another line. So we're going to start with parallel lines. So just to review here, a parallel line is a line that never crosses another line or two lines that never intersect. So what we're going to do is we're going to compare this graph of these two compare the graph of these two parallel lines and see if we can find their slopes and see how they compare. So let's take a look at the red line first. So we need 2 points to find slope. So we have a point here at -3, 0, and a point here at, let's see, -1, 1. So we compare their rises and runs. We rise 1. So rise plus 1, run plus 2. So that makes the rise over run 1 over 2 for the red line. We're going to do the same thing for the blue line. So we find a point here at -2, -2, and at 0, -1. So again, the rise here is going to be 1. The run here is going to be 2. So the slope of this blue line is going to be 1 over 2. So what we should notice is that since these two lines are parallel, their slopes are the same. So parallel lines have the same slope. All right, so now we're going to determine if these lines are parallel very quickly. So we need to find the slopes of both lines and then compare to see if they're the same. If they're the same, then we can say the lines are parallel. If they're not the same, then the lines are not parallel. So since this first equation is in standard form, I can use the shortcut m equals -a over b to find the slope. So in this case, the a value is 2. So the slope is going to be -2 over the b value, which is 6. So that's going to reduce down to -1 over 3. The second equation, all I have to do to find the slope, since it's in slope-intercept form, is see what is attached to x. In this case, the slope for the second equation is going to be m equals -1/3. So we ask ourselves again, how do these two slopes compare? In this case, they are the same. So we're going to say these lines are parallel. Okay, on the second equation, the second problem here, we're going to take out both equations again, and we hope that their slopes are going to be the same so we can say they're parallel. But if they're not, then we're going to say that they're not parallel. So again, we have a standard form equation, ax plus by equals c, so we can use the shortcut m equals -a over b to find the slope very quickly. So the first equation is going to end up having a slope of -a, which is 6, so -6 over b value of 8, which reduces down to -3 over 4. So now we need to check the other equation, see what the slope of the second equation is. So in the second equation, again, we're just in slope-intercept form, so we ask ourselves what is attached to x. In this case, it's +3/4. So you have to analyze the slopes now, see if they're the same. In this case, one of them is +3/4 and one of them is -3/4, so these are not the same. So we're going to say these lines are not parallel. All right, so let's go to number 3. We're going to apply the same strategy here on this one. Again, we just need to compare the slopes and see if they're the same or not the same. So again, first equation in standard form. So we're just going to use m equals -a over b. So that's going to be equal to -4 over b, which is 6. So it's going to equal -2/3. Again, this last one's in point slope this time, so I need to, instead of seeing what's attached to x, I need to see what's going to be attached to x. So in that case, it's what's out in front of the parentheses here. So our slope here is +3/4. So I compare my slopes again. The first one was -2/3. The second one was 3/4. So these are not the same, so we're going to conclude that these lines are not parallel. All right, so now we're going to take a look at how we kind of see it in a testing situation here. So we're going to write a standard form equation of the following line that is parallel to the graph of f of x, but it goes through the point g of -2 when g of x equals 5 over 2x plus 10. So we know that we want to be parallel to f of x, so that means our slope needs to be the same, so same slope. So let's find the slope of f of x and see what it is. So we need to find 2 points that we cross through here, and it looks like one point for sure is going to be, let's see, there's one at -5, 3. The next point is going to be at 3, comma 1. So let's look at our rise. So our rise here is 1, 2. Then our run is 1, 2, 3, 4, 5, 6, 7, 8. So we rose 2, so negative 2 over 8. So that's going to give us a slope of negative 2 over 8, which equals negative 1/4. So we probably had another point at down 1 over 4. So down 1 over 4. 1, 2, 3, 4. Yes, we did actually. So we had one at negative 1, comma 2 as well that we could have used. All right, so now knowing the slope, we now need to know a point that we pass through so we can use our point slope formula. So let's plug in our negative 2 in place of x so that we can get an output to go with that as well, so that we then have an xy pair. So we're going to rewrite this equation, g of x, and so instead of x, we're going to replace the x with a negative 2 equals 5 over 2 times negative 2 plus 10. So we notice our 2 is going to cancel out partially with our negative 2 up here to leave a negative 1 on the top. So we end up with g of negative 2 equals 5 times negative 1, which equals negative 5, then plus 10. So our final g of 2 is going to be g of negative 2 equals 5. So that represents the point negative 2, comma 5, because I plugged in negative 2 for my x and I got out 5 for my y. So now we have to use point slope formula with our point of negative 2, 5 and our slope of negative 1/4. So we go y minus y1 equals m times x minus x1. So then we substitute in, we have y minus our y from our point is 5 equals our slope, which is negative 1 over 4 times x minus our x from our point that we were given, which was negative 2, which is the same, when I subtract a negative, that's the same thing as a plus. So then when I distribute here, we end up with y minus 5 equals negative 1/4 x. Then 1/4 of 2 is going to be negative 1/2. So the only thing I have to do now is add 5 to both sides. So instead of adding 5 here, I'm going to want a common denominator here. So 5 is equal to 10 over 2. So I'm actually going to add 10 over 2, which is going to give me a final answer of y equals negative 1/4 x plus 10 over 2 minus 1 over 2 is going to be 9 over 2. And that's going to be it. All right, so now we're going to write the equation. Try some more examples of writing equations of parallel lines. So now they said I'm parallel to the line 5x minus 2y equals 10, and I'm going to go through the point negative 3, 6. So again, parallel, anytime I see parallel, I need to think same slope. So I'm going to use the standard form shortcut here, m equals negative a over b. So my slope here should be negative 5 over 2. So now I know my slope, and I know what point I go through, so I'm going to use point slope formula. So y minus y1 equals m times x minus x1. So we end up with y minus our y value, which is 6, equals negative 5 over 2 times x minus negative 3. Again, when I subtract a negative, I end up with an addition problem. So then I'm going to distribute my negative 5 over 2 to get me y minus 6 equals negative 5 over 2x. And then I'm going to do negative 5 over 2 times 3. That gives me negative 15 over 2. So then all I have to do now is add 6 to both sides. But again, I'm going to need to keep a common denominator here. So I'm going to realize that 6 is the same thing as 12 over 2. So I'm going to add 12 over 2 to give me a final answer of y equals negative 5 over 2x minus 3 over 2. Because when I take negative 15 over 2, add 12 over 2, I end up with negative 3 over 2. All right, so now I want you to pause your video because I'm going to give you a chance to work this next problem on your own. So pause for a little bit, then come back and check your work. All right, so now check out the answer, make sure it's right before moving on. If you have any questions, just reach out to your teacher here and figure out what's going on. All right, so now we're going to work towards perpendicular lines. So perpendicular lines are lines that intersect at a right angle. So we're going to do that same test here. We're going to find the slopes of both the blue and red lines and see how they compare. So we're going to use the point here, negative 4, 0, and then we're going to go down and use the y-intercept here of 0, negative 1. So the rise of the red line is negative 1. The run is 1, 2, 3, 4, so 4. So the slope of the red line is negative 1 over 4. The blue line is going to be, let's see here, we're going to use the y-intercept of 2. And you're going to use the point negative 1, negative 2. So we'll look at the rise again. The rise is 1, 2, 3, 4. The run is 1. So slope is 4 over 1. So you should notice two things here. Between these two, I did flip them over. So I flipped from negative 1/4 into 4 over 1, but I also changed the sign. So what we're going to say is that perpendicular lines have negative reciprocal slopes. All right, so let's try some out. All right, so let's find the slopes of the first line. So the slope of the first line, remember this is standard form, so go m equals negative a over b, which equals negative 6 over 2. So that equals negative 3 over 1. The second one, we have the slope is 1/3. So m equals 1/3. Are these two negative reciprocals of each other? Did they flip? Yes. Did they change signs? Yes. So these two lines are perpendicular. Now let's try the same thing on the next one. All right, so we have standard form again. So m equals negative a over b. So that equals negative 2 over 3. The next slope again is in slope-intercept form. So our slope is positive 2 over 3. So you ask yourself, did you flip them? No. Did you change signs? Yes. So these are not exactly negative reciprocals, so we're going to say not perpendicular. All right, so now we need to write an equation that's perpendicular to the x-axis and has the same x-intercept as y minus 4 equals 1/2 times x plus 2. So if I'm looking at the x-axis, this is a horizontal line. So if I want to be perpendicular to it, I need to be some sort of vertical line. So the hint they gave us to where we cross at is that we have the same x-intercept as y minus 4 equals 1/2 x plus 12. So what we're going to do here is we're going to plug in 0 for y, because on the y-axis y is always equal to 0. So we're going to say 0 minus 4 equals 1/2 x plus 12, or sorry, plus 1/2 times x plus 12. So we're going to distribute the 1/2 to get negative 4 equals 1/2 x plus 6. Then we're going to subtract 6 on both sides to try and get x by itself now. So we get negative 10 equals 1/2 x. So then to get rid of the 1/2, we just multiply both sides times 2. So we get x equals negative 20. So again, since we cross at negative 20, this is going to be a vertical line. So it's going to be a vertical line that passes through negative 20. So our final equation is actually going to also be x minus 20. So now we're going to pause the video here to give you a chance to work this one on your own. All right, go ahead and pause so you can take a quick look at your answer, then we're going to proceed from there. Okay, go ahead and pause the video again to take a quick attempt at this problem. Then we're going to come back in just a minute and see what we did. All right, so take a chance to review this question now. So you should end up with y equals 4x plus 5. Alright, now take a crack at your exit ticket.